and gents, we're going to go through this fast. I just decided to make a video real early this morning so you guys can have time to work. So, first of all, the topic for today is just average rate of change versus instantaneous rate of change. There are a couple of things that you need to be able to see. First of all, this true and false. This is something from your homework. Hey guys, just take your derivative of this, power it down, you guys should be fine. So I wanted to make sure I pointed that out, and yes, I will tell you that the answer is true for this particular one. So what I really want to focus in on today is that we're going to be talking about something called average rate of change versus instantaneous rate of change. Average rate of change is finding slope. And when you find slope, you need 2 points. Okay? So when you think of an average, remember you always add things together. Well, guess what? You're going to have to add the things together and do some dividing with that also. So average rate of change, you need 2 points to solve this. For instantaneous rate of change, instantaneous is right at that second. You don't have 2 points. You're only going to use 1 point. And in order to find that instantaneous rate of change, it's the derivative. And we only use 1 point for this. So now the notation can get a little tricky on this stuff. So for the first one, and notice I've kind of color-coded my notes, it asks you to find the average rate of change over the interval. So the first thing that you need to understand is this is the x value of 3, and it's the x value of 3.1. Okay, now in order to think about that, my y value at 3 is going to be 3 squared minus 7, or 2. And my y value here is going to be 3.1 squared minus 7, which turns out to be 2.61. Okay, so I have 2 points. I have the point 3, comma 2, and I have the point 3.1, comma 2.61. Now, to find my average rate, so average rate of change, I am just going to take my slope formula and do it. So I'm going to have 2.61 subtract 2 all over 3.1 subtract 3, which gives me 0.61 divided by 0.1, which turns out to be 6.1. That is my average rate of change. Got it. Slope formula. No derivative, no anything fun. The wrong line there. The instantaneous rate of change, that is when I take the derivative. So at an instant, I have got to take my derivative, y prime. Okay, so the derivative is 2t. Got it. Done. Now, it asked me at the endpoints. So an endpoint, one endpoint is 3, and the other endpoint, so my derivative there, y prime would equal 6. And the other endpoint is 3.1. So y prime would be 2 times 3.1, which turns out to be 6.2. This is one instantaneous rate. This is the other instantaneous rate. Okay, that's pretty much average rate of change. Now, continuing to talk about different things, velocity is an application of instantaneous rate of change. Guess what? Velocity is going to equal derivative. Remember we said that this is going to be an application of it. Okay, we're almost done. So average velocity is going to be finding slope. Notice the word average, you got to have 2 points. So here we go. Let's take a look here, and I'm going to color code just like I did before. If something's an average, it's going to be red. If it's an instantaneous, it's going to be blue. A ball is dropped from a height of 100 feet, s in the air, at a time t, and here is my equation. Yep, we're going to learn how to build this equation in a second. What is the average over the interval? So that means x equals 1. My y value would be, when I plug that in, negative 16 times 1 squared minus 100, which means that that is an average, plus 100. The average velocity, or I'm not average velocity, my y value is 84. That's the 0.184. Okay, so then if my x value is 2, with y equaling negative 16 times 2 squared plus 100, the y value turns out to be 36. So that is the 0.236. So I've got my 2 points. So now if I'm finding average, average is just slope. So my average velocity in this case is going to be 36 subtract 84 over 2 subtract 1, which turns out to be a negative 48. And for those of you who've done physics, feet per second, yeah, we're in feet per second instead of meters per second. Okay, next page. So for this next page, instantaneous velocity, soon as it is instantaneous, it is now my derivative. Okay, so position function. This is something I assume you know. A position function, oops, let me change colors since I'm not going to be instantaneous or anything. Position function, you guys know, is your height. H-E-I-G-H-T. So, what do you guys know? V of O is your initial velocity. I assume that you guys have seen that in science class before. And then your S of O is your initial height. So you're going to have to be able to make your own equations. So at time equals 0, a diver jumps from a board 32 feet above water. This is my initial height. His velocity is 16 feet per second. That is my V of O. Write the position function for the diver and then answer the following questions. So my equation's just going to be S of t would equal negative 16 t squared plus 16 t plus 32. Okay, so when will the diver hit the water? This is not calculus. This is a pre-calc problem. Pre-calc problem because I'm not taking a derivative of anything. So think of the little guy standing on the ledge. Here's the water below. He falls into the water. When does he hit it? He's going to hit that when the position equals 0. He's at 0 level, water level. So all I'm going to do is set negative 16t squared plus 16t plus 32 equal to 0. Notice I didn't change colors because this is not a calculus problem. So I see there's a 16 I could take out of everything. In fact, I'm going to take out a negative 16 because that's going to give me a positive t squared, a minus t, and a minus 2 equals 0. So negative 16 t minus 2 and t plus 1 would equal 0, and negative 16 would equal 0 using zero product property. T minus 2 would equal 0, and t plus 1 would equal 0. Hopefully you remember your pre-calc. So I get a no solution here because that doesn't make sense. Time would equal 2, or time would equal negative 1. Negative 1 doesn't make sense. You can't have a negative time. So at 2 seconds, he hits the water. Okay, as I said, no calculus there. So now, what is the diver's immediate velocity? Immediate means instantaneous. Instantaneous means I need to find my derivative. Okay, so my function as a t, oops, that's average color. My velocity is finding my derivative. So s of t, my original function is negative 16t squared plus 16t plus 32. My derivative is going to be negative 32t plus 16. So now at time 2, so s prime of 2, finding the instantaneous velocity, that's negative 32 times 2 plus 16. That would give me, he's traveling at negative 48 feet per second. That's the new stuff for today. Instantaneous, take the derivative. Average, you need 2 points. Last problem here. Find the volume of a cube is here. Find the rate of change of the volume. Rate of change, it doesn't say instantaneous, it doesn't say average. If it doesn't say anything, we're going to go with the instantaneous. It has to say the average. So to find instantaneous, I need to, step 1, find the derivative, and then step 2, plug in the value. Okay, we've been doing this. So volume equals E cubed. Volume primed would equal 3E squared. Take the E, plug it in. 3 times 4 squared is going to give me 48. And this would be centimeters per whatever the time is. Okay, so notice it's not an average. They gave you 1 point only, so that's what makes it not an average. Good luck, ladies and gents.